Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Ness. I am with Embedded Computing Design. This week we have a pretty regular guest now, Steve Hanna, distinguished engineer from Infineon. How you doing, Steve?
Doing great, Rich.
I got to say, there's two reasons why you keep coming back. One is that the topics that you're an expert in are so close to what the audience does. And secondly, I've always said you have this knack for being able to explain things that taking super complicated subjects and making them understandable for people at all levels of technology. And I thank you for that.
Well, thank you, Rich. I sure enjoy it.
So the subject today is something that you and I had a discussion about, and I said, this is something we should do a podcast about. Um, when you have an embedded device, you're constantly updating it to make sure, for lots of reasons, but one of those is security for sure. You need to make sure that you have the latest security on your device. So you're continually updating these patches onto your device. Sometimes you're talking about devices that have been out in the field for quite some time. So my question to you at the time was, well, you don't have infinite space to keep uploading these patches. At some point, you're going to run out of memory space. Then what do you do? And I know when I posed that, you got a big smile on your face because this is not something that is new to you, but it's certainly new to me, and I'm guessing it's new to the audience. What's the answer? I don't think there's an easy button you push to fix here.
There's no magic easy button here, but this is a topic that concerns all of us because, as we all know, software just seems to get fatter and fatter. And even if you're not adding new features, you're fixing bugs and security vulnerabilities, and that just makes the software a little fatter every time you do a firmware update. It's gotten a lot worse in the last few months because we've realized all of a sudden AI now has the ability to find cybersecurity vulnerabilities at an incredible rate. And we're seeing 10x increase in open source projects having to patch vulnerabilities, sometimes even more than 10x. So when you
Is that a
design,
good thing or a bad thing? I mean, are we just finding the bugs faster?
well, you could argue it's a great thing. We want to find those bugs and fix them. On the other hand, it's not so good if I shipped a product a few years ago expecting I was going to fix 10 bugs a year, 10 security vulnerabilities, do 10 patches, and now I'm doing 100. Now I could easily run out of patch space long before the lifespan of the product is exceeded. So
But do
problem
you
we're
ship a product with the expectation of having to fix bugs? Like, I mean, aren't engineers perfectionists? And you say, I don't have any bugs in here. You're introducing something completely different now, saying, well, I know I'm going to have to fix X number of bugs.
Oh, come on, Rich. In your first engineering project in school, you discovered that you were not perfect when you wrote your first code and it wouldn't even compile. So, yeah, I think we all know or should know that there are bugs in all software, and some of those bugs are security vulnerabilities that need to be fixed. So I hope you planned on some level of patches, but the problem is it's now 10 times as many patches as you planned on. So you're going to run out of patch space 10 times faster than you thought because your software is just going to be growing enormously and rapidly. So that's the problem. And go ahead.
Okay, that's the problem. What's the solution?
Well, basically, you have to put your firmware on a diet. It's not easy. It's painful, like dieting always is. But here are the steps that you can use. Number one, you can look for ways to shrink your code size. Now, you probably did some of this before you shipped the product originally, but there are always opportunities. Stripping out software that's not needed, changing your compiler flags. That's an easy thing to do. Just tell the compiler to optimize for space, not speed, and then recompile. As long as you're not building real-time systems, that's not a problem. You can potentially find some dead code and take that out. For example, maybe in your build you have some software that's just not used, some programs. You might even think about stripping out certain features that are very rarely used. Another thing you can do, and this can be a great way to find extra space that you can trim, is to shrink your data size. Because a lot of times there's actually more data than code, static data, things like string files. Or if you include any sort of graphics, videos, or sounds, if you have any sort of user interface in your product like that, those can get really large, and you might compress them more tightly or just get rid of that stuff because we're talking about embedded systems here. Maybe you didn't need that. Another thing that you can do that people don't think about is move from having a global software image to having one per region. That way, you don't have to have all the translated versions of the strings in your software, but just the one local version. Other things that you can do, make your software update process more space efficient. I want to talk more about that, but not right now. Also, if you get to the point where, I've squeezed it as much as I can and I'm still running out of memory, you might prioritize your bug fixes and put in the ones that are really severe and prioritize those first. You might even strip out some of the bug fixes you put in before. And if you find a situation that you've done everything you can and you still can't fix these security vulnerabilities, then you have a device which is effectively permanently vulnerable. And you have options even there. You could, for example, say, we're going to strip out certain features. We're going to remove the web browser from the smart fridge. We're going to take out some of those features so that we can still continue providing security patches for this, especially if you made a promise to your customers that you keep on making security updates for a 10-year period, and now suddenly you find yourself up the creek, so to speak. That's an option for you.
Are you making an assumption that the person doing the patches, who's uploading the patches, is technically astute, who's able to do these things that you're talking about? Because a lot of times you might just have some administrator who's just knows that he hits an update button and it happens automatically.
Yeah, I agree. I'm thinking that the person, in my experience, the person who's writing embedded systems firmware is technically astute. Mm-hmm. And that's the person who has the opportunity to take these steps. You have to be pretty good at writing firmware to get it to run on an embedded system. Sometimes you have to write machine language or assembly language, device drivers, things like that. So, you're pretty well up there if you're writing embedded system software. Now, that's not the person who's pushing the software updates out to the update server, but that is the person, your software developer, your firmware developer, who's going to have to make these tough calls about how to squeeze things.
What about adding more memory? I'm a little surprised that you didn't offer that as a potential solution.
With most embedded systems, if it's already out in the field, that's not an option. You're not going to ship the customer a new motherboard or, add memory to something that's out in the field. You might be able to do it for a new spin of your product, yes, but not for things that are in the field.
Okay, so I'm out of space. I know my system is vulnerable. Do I just lay low and keep my fingers crossed?
No, at that point, you need to notify your customers about the problem. And then you have to decide, are you going to EOL the device or take one of those other options that I talked about, removing features from it? Then you can fit the security updates. Squeezing it, put it on a diet, sure, then you can do that. If it turns out that it's unsafe, you might have to remotely brick the product. But I do want to get back to that thing I mentioned about changing your firmware update process. Mm-hmm. A lot of embedded systems use what's called A/B updates, where there are two copies of the firmware on the system at any one time. There's the active one, and then there's an extra that you're uploading the firmware update into. That way, if somebody turns off the power while you're uploading downloading the firmware update into that extra copy, well, you haven't heard anything. The active version is still fine. People have a tendency to do stupid things like that. So that's an A/B update system. You download the new version into your B slot, and then you reboot and go with trying out the new version. And if it works, great. And if it doesn't, you fall back to the A slot. Well, that requires 2 full copies of the firmware image in memory. And if you're doing that, there's an opportunity here to put the second copy on a diet so that you can have copy A be the full firmware, copy B be a slim version of the firmware, which is just designed to go out and get a new copy of slot A. So you're requiring effectively 2 firmware update steps in order to do a full firmware update. But with this clever mechanism, you could have, say, almost double the size of your firmware without running out of memory. It doesn't always work, but it depends on how you're designed it, but it can help.
You're not suggesting going from an A/B update to just A and getting rid of B altogether.
No, because then your reliability is out the window. I'm just suggesting that you alternate full featured update with tiny update whose only purpose is to download the next full featured update. I think you see what I mean.
Yep. Yeah, I was just looking to use the cross my fingers method one more time.
I wouldn't advise it. You're going to have a lot more customer support calls when people pulled the plug at the wrong time because they were frustrated.
Do you see today's designs going out with a lot more memory just for this reason than we did previously?
Yes, absolutely, because we can see the trajectory that firmware updates are coming more frequently, security vulnerabilities are coming more frequently, and therefore we need to budget for more rapid growth in software firmware size. Of course, it's not just about firmware. There are other things that you need to store, like keys, and you need to store those into a secure MCU like the PSOC Edge, or a security chip like the Optega Trust M. But really the firmware issue and the shall we say, obesity issue really mainly applies just to firmware.
Very good. Very good. This is a very important topic, and I'm really glad we were able to cover this. I think people really need to understand what the issue is here.
Yeah, if it hasn't hit you yet, it will be. AI is coming for your firmware, just the way it might be coming for your job.
The topic for the next podcast. Very good. Thank you very much, Steve. As I said, you described this in a way that pretty much everybody can understand.
Yeah, we're all fighting the battle of the bulge one way or another.
That was Steve Hanna, a distinguished engineer with Infineon, and I'm Rich Nass with Embedded Computing Design.